Hello, welcome to Maths with EJD. In this video, we're still talking about circles, and here our focus shifts to tangents and chords of circles, right? I mean, let's come here first. If you have a circle like this. So any line that touches the circle at, oh, it doesn't cut the circle, just touches the circle. I'm not doing a great job of this. Okay, any line that touches the circle at a single point is called the tangent to the circle. Okay, and then we also have what you call a chord of a circle. So any line that joins any two parts of the circle internally. Of course, it can only happen internally. That is what is called a chord of a circle. Okay. Then we have other things. So in that case, now it would mean that a diameter of a circle is a special kind of chord. Then you have things like the normal to a circle or the normal to the tangent of a circle. So if I bring this now and I have another line and it makes 90 degrees with the tangent, this is what is called the normal to the tangent of the circle. So the line that makes angle 9. So the tangent touches the circle at a single point. It doesn't cut through the circle. Then the normal to the tangent of a circle makes an angle of 9. The line that makes an angle of 90 degrees with the tangent. And based on what we learned about lines previously, it means that the product of the slopes of normal and tangent will be -1, or the tangent of one will be the negative inverse of the other. And then for a chord, it's just a line joining any two parts of the circle. Okay? That I think that foundation is necessary for what we are going to consider. So tangents and chords, right? Um, so talking about the equation of a tangent and chords. First of all, we talk about equation of a tangent to a circle. We already know the equation of a circle passing through the center, for instance, to be x squared plus y squared equals r squared. So we want to derive the equation of a tangent to a circle. So I'll just go through the derivation. So I won't bother, writing it out because it's all written here. The equation of a tangent to a circle. So we know that a circle at origin, you know, to derive that, the circle at origin, equation of circle with center at origin and radius r is x squared plus y squared equals r squared. And then if we suppose that x1, comma y1 is a point on the circle, we already know that for x1 and y1 to be a point on the circle, it means that the square of x1 plus the square of y1 should be equal to the square of the radius. That is established. We saw that in the last video. So since it lies on the circle, it means that x1 squared plus y1 squared is equal to r squared. Established. Then we go to step 1. So the general equation of a line. No, we're talking about uh, equation of a tangent to a circle. And from what I showed you, a tangent is a line that touches the circle at a point, right? So, and that's why we're talking about equation of a line. And previously we talked about lines, right? So general equation of a line is such that we have y equals mx plus c, where m is the slope and c is the y-intercept. Then step 2 now, if we take it a line, the line passes through x1, comma y1, which lies on the circle. So we say since the tangent must touch the circle at x1, comma y1, then we say that y1 will be equal to mx1 plus c. All right. And c here will be y1 minus mx1. So the equation of the line then becomes y equals mx plus c. You know, this c now. All right. So the slope of the line, that line itself, x plus the y-intercept, which we can get from here to y1 minus mx1. All right. So then we talk about the distance from center to the line. Distance from the center of the circle to the line itself. So of course, that'll be the radius kind of. So we can rewrite the line in standard form to say we have mx minus y plus y1 minus mx1 equals 0. So here now a is this m now, the coefficient of x. Then b is the coefficient of y, that's -1. And the y-intercept c is y1 minus mx1. So we can say that the perpendicular distance from the center 0, 0 to this line will simply be d equals absolute value of a times 0 plus b times 0 plus c all over square root of a squared plus b squared. And then we see that that is a, we know a is okay, this is a times 0, then b times 0. The only thing we have left is c. So c now is y1 minus mx1 over square root of a is m, b is -1. So that's absolute value of y1 minus mx1 all over square root of m squared plus 1. So then we talk about the tangency condition. So for the line to be tangent, this distance must equal the radius. So the distance we derived up here, this d, must be equal to the radius, right? So, and if we simplify that, simplification shows that squaring both sides, we have, if you square this and you square this, the square root will be gone here, and this is r squared. So you have y1 minus mx1 all squared all over m squared plus 1 equals r squared. So we can tidy things up. So we have y1 minus mx1 all squared equals r squared into m squared plus 1 squared. So we can expand this, right? If we expand this, we have y1 squared minus 2m x1 y1 plus m squared x1 squared. And that is equal to r squared m squared plus r squared. So now if we use r x1 squared plus y1 squared equals r squared, okay? Then we say that this is where do we even have this x1 squared? Yeah, this x1 squared plus x y1 squared plus x1 squared. So we can say this is y1 squared minus 2m x1 y1 plus m2 x1 squared equals r squared plus m squared plus, this r squared now is x1 squared plus y1 squared right here. So, and then we can cancel, if we can cancel y1 squared like this. So we have 2m x1 y1 plus m2 m squared x1 squared equals r squared m squared plus x1 squared, because y1 squared has cancelled y1 squared there. Then we can rearrange that now to be m squared. We have m squared common here. So m squared into x1 squared minus r squared, then minus 2m x1 y1 minus this x1 squared, and that is equal to 0. But we know that x1 squared minus r squared is equal to minus y1 squared. So we can use this, take this back. We have minus m2 squared. That's m2 squared times minus y1 squared. That's minus m2 squared y1 squared minus 2m x1 y1 minus x1 squared equals 0. So we can multiply through by minus 1 or divide through by minus 1 so that we have m1 squared, m squared y1 squared plus 2m x1 y1 plus x1 squared equals 0. So this quadratic confirms there's exactly one slope m satisfying this condition. So in that case, we get our final result. So the final result will just be, hence the equation of the tangent to the circle x squared plus y squared equals r squared, rather, at the point x1, y1 is xx1 plus yy1 equals r squared. So we're going to get a set of x1, y1 from here that satisfies this equation perfectly, and that is equal to r squared. Okay, that's how to derive that. We should do some work with that. So if we talk about circle with center HK now, the first one we did was for circle at the center 0, 0, circle at origin. But for circle with center h comma k, so we see that the equation of the circle will be x minus h all squared plus y minus k squared equals r squared. Then let the tangent at point x1, y1 be. So the tangent will now be x minus h into x1 minus h plus y minus k into y1 minus k equals r squared. That's the tangent. So derivation, the circle condition for point x1, y1 will be x1 minus h squared plus y1 minus k all squared equals r squared. The equation of tangent is obtained by replacing x minus h squared plus y minus k squared with this expression we had up there, x minus h into x minus h plus y minus k into y minus k. Thus, we have this to be equal to r squared easily. So instead of having x into x1 plus y into y1 r squared, we just have x minus h, then x1 minus h plus y minus k into y1 minus k equals r squared, because the center is h comma k. Then tangent from an external point now. So if you want to find tangent from an external point, so if we have point x naught comma y naught lying outside x squared plus y squared equals r squared, then the equation of tangent will simply be x naught plus y naught equals r squared. Okay, so the derivation of that is simple. Any tangent from P of x naught y naught to the circle has the equation of the form ux plus vy equals r squared. So since x naught y naught lies on it, then ux naught plus vy naught is r squared. Also, condition for tangency implies that uv is proportional to x naught y naught. So u is x naught and v is y naught. So hence, we just have x naught y naught equals r squared. So it's basically simple. So the tangent to a circle will simply be x1. The point at which the line touches the circle will be coordinates x1, y1. So we just have x1 plus yy1 equals r squared. Then if it is from an external point, x naught, y naught, it will just be x naught plus y naught equals r squared. So let's take some examples and see how things go. So find the tangent to x squared plus y squared equals 25 at 3, 5. So we know equation is xx1 plus y1 equals r squared. So x1 is 3, y1 is 4. So that we just have x times 3 plus y times 4 equals the radius, of course, we know that will be radius squared is 25 for sure. So that will just be 3x1, 3 times x1, x plus 4 times y. That's 3x plus 4y equals 25. And that's the equation of the tangent to the circle. Of course, you can visualize that graphically. So x squared plus y squared equals 25. And then we have 3x plus 4y equals 25, right? Okay. X squared plus y squared equals 25. Okay. And then we have 3x plus 4y equals 3x plus 4y equals 25 also. So you can see that that tangent now touches the circle at this given point 3, this point 3, 4. You can see that already. That's tangent to that circle at that point for sure. So then we can talk about length of tangent from an external point. So if you want to calculate the length of a tangent from an external point, so in this case, if of P given which is x naught comma y naught lies outside of x minus h squared plus y minus k squared equals r squared, then length of tangent L is square root of x naught minus h squared plus y naught minus k squared minus r squared minus the radius, right? So the derivation is also simple. So distance from P of x naught comma y naught to center h comma k is d, which is square root of x naught minus h squared, h all squared plus y naught minus k all squared. So the length of tangent will be given by length equals distance, all right, the distance itself minus the radius, minus the square of the radius, so that L is square root of x naught minus h all squared plus y naught minus k minus r squared. So at the end of the day, all you need is you need point x naught, point y naught, and then you need the radius. Okay. So here now, and then of course you need the hk. So here, find the tangent line, find the tangent length from 7, 1 to x squared plus y squared equals 25. Here, of course, because the way the circle is now, it means it is at the origin. So h is 0, k is 0, and r squared is 25. So that means the length is square root of 7 squared, that's x naught squared, minus h. So h is 0. So that's 7 minus 0 all squared plus 1 minus 0 all squared minus r squared. So that so, so L is square root of 7 squared plus 1 squared minus 25. So L is square root of 49 plus 150 minus 25. That's square root of 25, which is equal to 5. Okay. Then we can talk about the equation of a chord with given midpoint, right? So just like you have here now, imagine that we now have a midpoint around here. So you are given this midpoint, say x1, y1, or something like that. Okay. So if x1, y1 is midpoint of chord, equation is xx1 plus yy1 equals x1 squared plus y1 squared. Okay. For chord now, instead of just r squared, now we have x1 squared plus y1 squared. So the derivation is such that so let chord endpoints be a of x2, y2, and b is x3, y3. So the midpoint condition, of course, is simply x2 plus x3 over 2, y2 plus y3 over 2, which we can call x1 plus y1. So x2 plus x3 is 2x1, y2 plus y3 is 2x1. So both A and B lie on the circle, right? So if both A and B lie on the circle, of course, it's clear that for a chord, so this can be A, Okay, and this is B. So they both lie on the circle. So it means that the square, the sum of the squares of I mean, it means x2 plus x squared, x2 squared plus y2 squared will be equal to r squared, and x3 squared plus y3 squared will be equal to r squared too. Okay, so that's what we basically have here. So we can then subtract and simplify. The equation of chord then becomes xx1 plus yy1 equals x1 squared plus y1 squared. So we have example 3. So from example 3 now, uh, okay, find chord of x squared plus y squared equals 25 with midpoint 2, comma 3. So that'll just be xx1 plus yy1 equals x1 squared plus y1 squared. Okay, equals x1 squared plus y1 squared, like that. We substitute 2, comma 3. So just like you have here. So that's 2x, x1 is 2. So that's 2x plus 3y equals x1 squared, that's 2 squared, y1 squared is 3 squared, and that's 4 plus 9, which is 13. So you have 2x plus 3y equals 13. So again, we can demonstrate this to show that it's actually a chord that cuts that circle. So at 2, comma 3. So 2x plus 3y equals 13, right? So we have, okay, I can even continue. 2x plus 3y equals 13. So you can see it's a chord, uh, I think it's centered at 2, comma 3, something like 2, comma 3 or so, right here. Okay, 2, comma 3. It's actually 2, comma 3 here. If I expand, let's see. So this point is 2, comma 3, of course. So you can see that is a chord that cuts through the circle. Okay. So summary, we have tangent at x1. If you want tangent to a circle at x1, comma 1, comma y1, that's xx1 plus y1 equals r squared. If you want the length of tangent from x0 to y0, from an external point, so L is square root of x0 minus h all squared plus y0 minus k all squared minus r squared. Now, if the center of the circle is at origin, so that'll just be x0 squared plus y0 squared minus r squared, basically, right? So if you now want to find the equation of a chord with midpoint x1, comma y1, you have xx1 plus yy1 equals x1 squared plus y1 squared. Okay, so we can then talk about some practice questions which you can try your hands on. Okay, so for tangents and chords of circles now, find the equation of the tangent to the circle x squared plus y squared equals 16 at the point 4, comma 0. Of course, that's xx1 plus xx1, right? Plus yy1 equals r squared. So that will simply be 4, x1 is 4, y1 is 0. So that will be 4x plus 0 times y, 0 equals 16. So that will simply be 4x equals 16, meaning that x is equal to 4x equals 16, right? That's uh, x equals 4. Okay, so you have x squared, x squared, x squared plus y squared equals 16. Okay, so that simply means x is equal to 4. You can see it's actually a tangent as expected. So you can try your hands on these other ones. And with this, I come to the end of this interesting video about the tangents and chords of circles. We haven't said that a tangent of a circle is a line that touches the circle at a single point. It doesn't cut through the circle, right? And then a chord of a circle is a line that cuts through the circle, joining the circle, touching the circle at 2 points like that. Okay, let me know how helpful this is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much. If you have not subscribed, why not go ahead and do that right away? Don't forget to hit the notification bell too, so you can always get alerted each time a new video is released. All right. Having done that, don't forget you can take it further by clicking on join to become a member of the channel, and that comes with some special privileges. Okay. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.